Snowflakes seem like such an ordinary part of winter, especially here in Colorado. But in reality, the snowflake on your mitten is very special and much more complex than just your average fragment of ice. To start a snowflake, you first need to have a particle of dust, like Mr. Dust E. Bunny. The dust bunny needs to be in a cold and wet environment, like in the clouds. Once the bunny is in the clouds, the ice then starts to grow onto the dust bunny. Depending on the environment that the snowflake is in, different arms may either be longer or shorter, thinner or even flatter. Things such as temperature, humidity, and the distance the snowflake falls from the cloud affects how the arms of the snowflakes actually look. By having a lot of different branches, the temperature of the air is spread across a larger surface that then becomes the snowflake itself. The general appearance of a snowflake can be related to the atomic structure. Snowflakes are made up of multiple water atoms that are connected together. As two water molecules are put next to each other, they connect through hydrogen bonding. The bonds between oxygen and hydrogen molecules are hard to break. This is because of the polar characteristics of oxygen. Polar basically means that oxygen wants to have a lot of friends and keeps the hydrogens pulled very closely to itself. The oxygen does this by pulling the electrons from the hydrogen from the other water molecules around it. When putting a large amount of water molecules together, they hydrogen bond into a six-sided ring. The six-sided ring that the six water molecules come together to form is called a unit cell. Think of a unit cell like any other unit. They are a type of measurement. A unit cell is the smallest measurement for repeating chemical molecules. For snowflakes, when they freeze, they lock into that six-sided ring. By stacking multiple unit cells together, they keep the same shape but in a much larger form. Think of this process like stacking Legos or blocks. By adding them together, you may create something bigger, but it'll always have the flat sides and corners. Another crystal that you've probably seen in your life is table salt, which is otherwise known as sodium chloride. If you look really closely at sodium chloride, it's generally a very tiny cube. This is because the unit cell of sodium chloride is cubic. So, the next time that you find yourself shaking the snow from your hair or catching a snowflake on your tongue, you know just how special those tiny ice crystals really are. The end.